Okay, guys. So we have 8 people. So let's not waste time and get started. Today we will cover data envelopment analysis, and before that, a few announcements we have to make. One is assignment three. Assignment three, we had few problems. I think 2 or 3 questions had some range issues. So those have been updated, and I think it will be reflecting on your course portal as well. Please do go and check your course portal. If not today, I think definitely by tomorrow it should be processed, and you will have the updated scores for assignment three published on your dashboard by tomorrow. I think it should have already been updated. Just have a look at it. Number two, I have already shared the Excel files of our logistic regression, that Gradio demo, uh, multicollinearity, right? All these things have been updated, and I have sent them. I think it will be added under supplementary contents, right? So do have a look at them tomorrow. By tomorrow, it will be added to your portal. I've also given some practice problems for logistic regression, especially last class we had some new topics, right? How to interpret the coefficients of logistic regression. So those practice questions again have been sent to the admin team. They will update the course portal. It will be updated under logistic regression, non-graded assignment or practice problem. So it will be updated there, and do have a look at it. Anyways, we are meeting next week. So if you don't see them, we can again see, and we'll update them. Okay. So with this updates, let's get started with data envelopment analysis. And do you have any questions before we start? I hope I
Yes.
was. Yeah. Any question?
No, no, sir.
Okay,
Continue, sir.
sure. So did you guys see data envelopment analysis lectures?
And so before that, I just
Mm,
wanted to say one thing. See, few of your course recordings rights are not
mm.
available from the calendar. So when we go to that calendar, we just want to. I think some of it is having some access restriction kind of
Okay.
it request access. So if you can just help us in that matter, it will be great.
Okay. Okay. So you want the live session recordings for
Uh,
your.
yeah, for mostly your sessions, maybe TA sessions and the live sessions both, because all
Okay.
of them are there in the calendar. But when we click on the calendar, it's
Okay.
asking for access denied.
All right. So you are thinking this like Teams where all meetings recordings will be available there. I don't think so that that facility is available here, but we do have a YouTube channel. I will send you the links. So I will upload all the live sessions done by Malola and myself and put it in a playlist, and then we will share the link of that. That is one thing. And TA sessions also similarly. Whatever sessions have been taken, I'll ask them to create a playlist out of it and then send a link. Both links I will share it together.
That will be of a great help, sir. And
Yes,
please
yes,
put
will
it on
do
the
it.
discourse or something so that we can access it. Thank you
Yes,
very
yes,
much.
yes. We'll send it as an announcement or email.
Okay, okay, that will be of a great help before the
Sure, sure.
end.
Pleasure, pleasure.
Yeah, thank you, sir.
We'll do that. Let me note it down so that I don't forget. Live session links. Noted. So, how many of you saw DEA videos, lecture videos? How many of you didn't see? So, this is important because I'm not going to give you any bonus marks for seeing the live sessions. But if you have not seen, I will do it differently. If you have already seen, I will do it differently. So, Anshuman, I believe you have seen the videos.
Take not seen, sir. Is
Okay,
Yeah.
maybe.
no problem. Did not see. Okay, because see, DEA is a 2 week content, right? We have 1 hour session today. The problem is, it will be very, very difficult for me to cover the entire aspect of DEA in this 1 hour. So, what I'm going to do, I'm going to cover only the important part of DEA from the exam point of view, right? I'm not going to solve the DEA problem on Excel and things like that because you are not going to do that in the exam. And we will understand DEA theoretically. Why are we doing this? What is the rationale behind DEA and so on? We will also work out some numericals on DEA, which is very, very important from the exam point of view. Okay.
Great, sir. Thank
Okay.
you.
But next week, please have a look at conjoint analysis and come. So that, see, the idea behind this live session is, if you had seen DEA videos and if you have come for this live session, your preparation for the end term would be completed, right? You don't have to again go and watch the videos before the exam. So that was the idea behind today's live session. Nevertheless, we will see what best we can do. Okay, so what is DEA? Data envelopment analysis. And what are we doing here?
Basically trying to get efficient.
And what is efficiency?
Efficiency is the output given upon the
Output
input. Taken.
Output by input, right? So there are many ways of talking about efficiency. Some examples of efficiency. Can you give me some examples of efficiency? Where do you measure efficiency?
Yield of reactions.
Yield of reactions. Okay. Okay. Some more
examples that everybody can relate to? Any process efficiency.
Process efficiency. If you have a production line, so how efficient is this production line? How efficient is the other production line? Right? Process efficiency. What else you can think about? Efficiency.
Sir,
Fuel efficiency.
Yes, one by one. Yes, sure. Go ahead.
Sir, I am telling that can we use efficiency in Taraju in balancing?
Balancing. Again, certain things are very specific. Okay, only the people who know that area well can comment about it. Definitely, efficiency is there everywhere, right? If you talk about say sales offices 1 and sales office 2, which is more efficient? Because not all the offices will have equal amount of labor, equal amount of budget. So they are very different. If you take two offices, right, even people who are working in corporate, right, they will have one office in Chennai, one office in Bangalore, right? Bangalore team size will be very big, Chennai team size will be very small, but they all work on similar goals. So which is more efficient, Chennai office or Bangalore office, right? The best example I could think of is, right, cricket. If you take cricket, right, tell me 2 stars or 2 or 3 stars. We'll take Sachin, Virat, right? One more.
Dhoni, sir.
Dhoni. Okay. So these 3, right? Can you compare them? Can you compare Sachin versus Virat? Can you compare Sachin and Dhoni?
No, but we can compare their stats.
Yeah, you can compare their stats. Yeah, we are not talking about qualitative study here. So in business analytics, everything is quantitative. So what is qualitative? Who is more cool-headed? Who has a better personality? Who is more pleasant? And all those things. So those will be qualitative stuff. Here we are purely dealing with quantitative stuff. What is quantitative? Mean, median, mode, strike rate,
what
number
we can quantify.
Quantify, yes. Anything that is quantifiable, that is what we are dealing here. So Sachin played in a different era. Dhoni played in a different era. I mean, Virat and Dhoni are more or less contemporaries, but Sachin and Virat, no, they played in different situations, different conditions. And Sachin has more runs. Virat has higher average. Virat has higher strike rate. Right? He has more centuries. So they are very different. How can you compare Sachin and Virat? That's my question. So DEA lets us do that. DEA tells us, is Sachin efficient? Is Virat efficient? First, what we will do, right? So we spoke about a couple of things. In cricket, what did we speak about? We spoke about average. We spoke about strike rate, hundreds, right? 50s, total runs, right? Let us say these are the metrics. So now don't bring in the concept of multicollinearity. Okay, so that is for prediction problem. Multicollinearity is a problem, but this is not a prediction problem. This is a prescriptive problem. So we can use all these stats, right? It is not going to harm us in any way. Fine. Sachin has higher average, right? Compared to Virat. Virat has higher strike rate compared to Sachin. Sachin has more hundreds, right? And Sachin has more 50s, right? Sachin has more runs, right? Okay. So in some aspects, Sachin is better, right? In some aspect, Virat is better. How can you compare them? For this, we solve a DEA problem for Sachin. First, we will solve a DEA problem for Sachin, where Sachin will try to maximize his own efficiency. Right? Sachin will maximize efficiency. How will he maximize his efficiency? By choosing the correct weights, right? So here, let's have another metric called balls faced. Let's say we are talking about test matches. Okay, so this could be an input, right? All these could be outputs. Output, output, output. Can you think about any other input? Well, the number of matches, right? This could be an input. Yeah, that is an output. Century, 100, hundreds. Okay, so we have two inputs, and we have 1, 2, 3, 4, 5 outputs, right? So what is efficiency? Output by input. So we have output 1 all the way till output 5 divided by input 1 and input 2. Okay, so now Sachin is solving a DA problem to maximize his own efficiency. And how does he do that? He is going to have some weights for, right, for his output. He is going to have some weights for his input, right? So here we are solving a linear programming problem where the decision variables are nothing but, what are the decision variables?
The weights.
Weights are the decision variable. U1, U2, all the way till U5, and I1, sorry, W1 and W2, right? These are the weights. Sachin is going to intelligently give weightage for each and every output and each and every input with the objective of maximizing the efficiency, right? And then whatever weights help Sachin maximize his efficiency, the same weights will be used on Virat to check, is Virat efficient relative to Sachin based on the weights of Sachin. So you're relatively measuring. First you compute the weights for Sachin, use the same weights, and then solve the DA problem for Virat, and then check whether Virat is efficient relative to Sachin. So you are not comparing apple with oranges. You are actually taking them on the same scale, and then you are trying to compare apple to apple. This is what we are doing in DEA, right? So here some theoretical concepts are important, right? Tomorrow when you talk about DEA, you have to talk about productive efficiency. So certain definitions are very well given in the lectures. Focuses on maximizing the output under given constraints, right? You want to maximize the output given the resources or inputs that we have. So here you don't worry about optimal allocation or optimal choice of products. You're not worried whether you're in the right market, you're selling the right product or not, right? We also assume that the technology doesn't change. So these are some of the assumptions of DEA, right? So if you have, in this lecture, we saw two examples. One is constant output, right? The output is constant for all the DAs or DMUs. Input will be different, right? If this is the case, right, we'll have something like this, right? So let's say this is 1, this is 2, this is DMU 3, 4, and 5. So which is the efficiency frontier here? Which DMUs are efficient here? So
1, 4, and 6.
1, 4, and 5.
Oh, sorry, 5.
Right. So these are efficiency frontiers. Similarly, if you have constant input and you have outputs are different for certain DMUs, then you will have something like this. So let's say 1, 2, 3, 4, and 5. Here, these will be the efficient frontiers. 3, 4, and 5 will be efficient frontiers. This is the envelope. Okay. So here, DEA measures, the most important thing here is DEA measures relative efficiency. First, you calculate individual efficiency for each DMU, and you must have set of DMUs. You build an optimization for each DMU. You define weighted ratio, since we have multiple weights and multiple inputs. Okay. For each output and each input, you will have an associated weight. Through that weight, we are playing this optimization game. Is it fine? So whenever you solve an optimization, you had something called what was that? Decision variable. What is the next thing? In a linear,
Constraints.
okay. So in a linear programming, what are the things that you will have? Decision variable, constraint. What else?
And the function that we have to minimize or maximize.
Objective function.
Objective function, right? And then non-negativity constraint, right? Sometimes this is very important. Without this, you will not get a feasible solution. So what is the objective function here? Maximize efficiency. And what are the constraints we have? Efficiency should never be greater than 1. It can be lesser than or equal to 1, right? No DMUs will have an efficiency of greater than 1, including the DMU for which you are solving the problem. No DMU can report an efficiency of greater than 1. That's the only constraint we have. Is that clear? Is it clear? Okay.
Yes,
Yeah.
sir.
Yes, sir.
I'll take the same example that we solved in the class, right? Here you have sales offices. 1, 2, 3, 4, and 5. Then you have the sales volumes, right? So let's say 11, next is 17, 58, 34, 50. Right? These are the sales volumes. And then you have number of leads. What are these leads? These are something like inquiries you have got from your marketing campaign or something. 10, 12, 23, and 20. Are these inputs or outputs? Sales and leads.
Outputs.
So tell me what is 015?
Output one of, no, sorry. Yeah, output one of, output fifth of, sorry, output one of the fifth DMU.
24,000.
Sales of the fifth one.
Okay. So here it is the first output and fifth DMU. So what is this? This is K. K is nothing but the number of DMUs we have. Here we have 5 DMUs. So in this case, this will be 24. Is it fine? So now tell me what is 023?
12.
Second output?
12.
12.
That's all. Right? So this is how you will interpret. Okay.
So one more time, please.
One more time, you want to know what is this 1 and 5?
Yes, yes, yes.
So this is the first output. So first of all, you have to decide whether this is output or input, right? If you have something like sales, number of leads, it is output. Similarly, if you have something like say budget and something like team size, what are these? What are these variables? Output or input?
Input.
Right?
Input.
So this is input 1. This is input 2. Let's also do that. Sales office. 1, 2, 3, 4, and 5. So 3 lakhs, 2.5 lakhs, 5 lakhs, 3.9 lakhs, 1.85 lakhs. Okay. Next is 13, 9, 7, 10, and 14. So now tell me what is I24?
10.
10.
I24 is 10. So this is the second input for the fourth DMU. Second input for the fourth DMU. So now tell me what is I12?
2.5 lakhs.
3 lakh.
2.5 lakhs. Okay. So what did we see? We saw that efficiency is nothing but weighted output by weighted input. So each DMU defines its own efficiency using weights they want to assign to their inputs and outputs. So EK is nothing but Y1K and O1K plus Y2K, O2K, Y3K plus O3K and so on, all the way till YMK, OMK divided by X1K, I1K plus X2K, I2K plus all the way till XNK plus INK. So what is K here?
K is DMs.
Number of DMUs. So this is
Yeah.
DMU1, DMU2, DMU3. You solve for a particular DMU. If you are solving for the first DMU, it will be like O1K plus O11 and so on. Right? First DMU, right? This K will be 1. K is the number of DMUs we have. So in the previous examples, we had 5 DMUs. N, what is N? Number of inputs we have. So in the previous example, we had 2 inputs. What is M?
Number of
Number of outputs. That's all. And what is Xij? Weight associated with
Input.
Input, yes.
Input I for DMU K. So this is the first input. This is the second input. So you have how many inputs? I inputs, right? Similarly, weight associated with the output. The weight associated with output is given by Y. Right? You have M outputs, you have N inputs. That's all. Okay, so now we are solving an optimization problem. Each DMU tries to maximize its own efficiency by adjusting the weights associated with output and input with the objective of maximizing the efficiency. The only constraint we had was no DMU can have
Efficiency greater
greater
than
than 1.
Yeah, that's the only comparison. That's the only constraint. And what about non-negativity constraint?
the weights can't be negative.
So XIK, YIK, they can't be negative, but they can be 0. Yeah. For all I's and for all J's, not for all K's. Why? Not for all K's, because we are solving for K, and you understand this? Why only K? Because we are solving for a particular DMU K. So you will not consider for all K's, because you are solving for one K and then you are comparing to the other case. And what is complex about this?
Actually,
Why
it's
is this very
non-linear.
difficult? Yes, that is there. One is non-linearity. Second, right, if you see the budget problem, so this is in lakhs, this is in tens, this is units, this is tens. So the quantum of the input variables are very different. So we have certain complexities, right? And we only know linear programming. We don't know non-linear programming. That has not been covered here. So what we do when you have a non-linear program, why is this a non-linear problem?
Actually, it's linear upon linear, so that could be anything.
No. So here, this is your objective function. You're trying to maximize this, right? You're trying to maximize this. Whereas this is a ratio. You have a numerator, you have a denominator. This is not a linear problem. So you are trying to linearize a non-linear problem. How will you do that?
Cap the denominator to 1.
Yes.
That's
so the step is to linearize the problem. You have a non-linear problem because it is a ratio, right? That is why we use linear programming because we want all the objective function and constraints to be linear, right? So it has to be linear in nature, and this is not a linear in nature. Therefore, we linearize the problem. So what is efficiency? You have a numerator, you have a denominator, right? Now we say that, well, I don't want a ratio, I want a single number, I don't want a ratio. So therefore, what we do? We equate the denominator to 1. And then we have a constraint that says that numerator by denominator should be less than or equal to 1. This was the constraint, right? Efficiency cannot be greater than 1. Can we write this as numerator is less than or equal to denominator? Right? You're just cross multiplying here. Right? Through this,
Yes,
what we do is we get rid of the denominator. We only maximize the numerator. And we set a constraint saying that numerator should be less than or equal to denominator. So through this, we are actually linearizing the problem. Is it fine?
Yeah.
Okay. Any questions so far?
No, sir.
no.
Okay. So let's take this problem again.
Sir,
Okay. Yes.
Sir,
Yes. Yes.
actually, sir, this above graph,
Hmm.
actually, what is lead, sir? Lead.
Lead means, okay. So since I worked in sales, I know what this is. Enquiries. So you call it as enquiries. So when you do a marketing campaign, right, some 15 people showed interest in your product. Some 10 people showed interest for sales office too. Right? You have a budget. If you have a budget, you spend it on marketing. When you do that, you get some enquiries. Those enquiries could be hot, cold, warm, or something. But so many people approached your office for inquiring about a particular product. That's all. Okay. So we will use the same table and try to. Can you cut this? Is it possible to cut something? No. Duplicate. Yes, I'm able to do it. Okay. I'll copy this. We'll try to solve the form. We will try to formulate this. Okay. So let's say that I want to formulate linear programming problem for sales office 1, DMU 1. Now tell me the objective function. What do you want to maximize? Assume you have 2 inputs and the output is something like 100,000. Huh? Okay, let it be something like this. 10 lakhs. It's a constant output for all the sales offices. Right? It's the constant output for all the sales offices. So now tell me, what is the objective function? We are solving the DEA problem for DMU1. Maximize?
Sir,
Maximize?
one more zero there.
Ah, okay. Yes. Yes. Yes, thanks.
So, sir, if there would be a 1 lakh, so always we will be in loss, isn't it, sir?
No. So
No.
problem here is, okay, I'm hearing echo. Can you mute? Okay. What I'm saying is, the inputs are very different. Each sales office has different inputs, 3 lakh, 2.5 lakh, 5 lakhs, and so on. But everybody should minimum produce an output for 10 lakhs. 10 lakhs worth of sales has to be done minimum by all the sales offices. If you do more, Well, it is not incentivized. I don't care if you do more. But I am assuming that every sales office must at least do sales for 10 lakhs. If you can do more, I don't care. So now you have to formulate linear programming problem for DMU1. Okay. So you have only one output, which is this into 10 lakhs. Right? This is your objective function. Subject to what? Subject to what? What is the first constraint?
The y1 into 10 lakh is less than or equal to weight 1 into 3 lakh.
That is there. And do you
Plus-
also have to set the denominator to 1? Type
Uh,
constraint. That is called a type constraint. So
Yeah.
x11 into 3 lakhs plus x21, I guess, into 13 is equal to 1. This is called a type constraint. Right? Next, let's
next,
talk about this is input 1, this is input 2. Again, y11 into 10 lakh is less than or equal to x11 into 3 lakh plus x21 into 13.
Yeah.
Okay. So okay. Next is
Next is
y11 into 10 lakh is less than or equal to
1.
x. What is this?
1.
1, 2.
Okay, we'll talk about that. This is the most confusing part, and therefore I will spend more time. Let me finish this and get back to 1 into 9. Y11 into 10 lakh is less than or equal to x11 into 5 lakh plus x21 into 7, and so on. It goes on for x4 and x5 as well. So now you guys were telling me, why are you writing x1 here? Shouldn't it be x21? Shouldn't this be x31? That was your question, right? Why is this y11 here? Why is this y11 here? This should be y, because we have only one output, so nothing will change. Everything is common here. Whereas here, you can ask me, why is this is x11 fine? This should be x21, this should be x31, next one should be x41 and 51. Why am I having x1 for everything, x11 for all the constraints? Why is this x21 for all the constraints?
Because we have to use the weights of DMU
Yes.
one only.
Yes, because x21 and x11 are the weights of DMU1 for which the efficiency of DMU1 will be maximum. Right? For this, you are also trying with the weights of DMU1, you are trying to check if other DMUs are efficient or not. You are checking the relative efficiency of other DMUs with regard to DMU1. That's why these are x11, x11, x21, 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 and so on and so forth. Is this clear? Is this clear?
Yeah.
So similarly, you can formulate this for sales office 2. Will you be able to do it? You can do the formulation for sales office 3, 4, and 5. So if you do the formulation for sales office 4, how will it be? x14. This will be x24. Right? For everything, it will be x24. Is it clear? What will be the y here? x14, y14. This is for DMU4. Is it clear?
Yeah.
Okay. So next comes, what is hypothetical composite unit?
Actually, the ideal state of an inefficient unit.
Okay. So if there is an inefficient unit, right, and you want to make it efficient, right, You have to go towards the hypothetical composite unit. Let's draw a graph. Right, I have two outputs, inputs and team size. Right. So now, right. So I have 1, 2, 3. Right. I do have 1, 2 here. Right. So now, what will be my productive efficiency frontier? So let me give names also. So let this be 1, 2, 3, 4, and 5. So what is my efficiency frontier? These guys, right? So my DMUs 1, 5, and 4 are efficient. 2 and 3 are inefficient. Do you agree?
Yeah.
Yes, sir.
So now if you want to make 2 efficient, what you will do? Draw a line from origin and connect it to 2. Similarly, draw a line from origin and connect it to 3. Right? So here what we are trying to say that this 2 should move towards the origin and meet the efficiency frontier here. Similarly, 3 from here has to move and come here. If 3 has to become efficient, it has to reduce the budget and it also has to reduce the team size. Both. You cannot only reduce the team size and become efficient. You cannot only reduce the budget and become more efficient. You have to cut down on both to become efficient. So if 3 travels from this point to this point, it is going to become efficient. So the reference unit for DMU3 are 5 and 4. Right? The reference unit for DMU2 are 1 and 5. Is this fine? Is this fine?
Yes, sir.
Sir,
Mm.
so is it echoing?
Is it?
Echo is coming from my side.
Equal? Can you repeat the question? I'm not able to understand. Maybe you're.
Okay. No, I was telling that echo was coming or not because I was going to ask.
Oh,
a
no
question.
echo. No echo now. Now please tell me, sir.
Okay. Okay. So you are telling that referencing is one the above 1 and 5. So how this reference is taking, like 5 and 4, how this thing is taking?
Because see, you have 3 here, you have the origin here. You join this 3 with the origin, and it is going to meet the production efficiency frontier at a particular point. So this point is between 5 and 4. So this 3 has to pass through this line in order to meet the origin. Similarly, the 2 has to pass through this line for intersecting with the origin. So these 2 will be the reference unit for DMU2. These 2 will be reference unit for DMU3 and so on. And if you solve it using linear programming and if you see the shadow price, right? Have you heard of this term, shadow price in DMU, in DEA? Generally, these 2 will have a non-zero shadow price. Similarly, these 2 will have a non-zero shadow price when you solve for DMU2, when you solve for DMU3. If you are solving a DEA problem for DMU3, what will happen? 5 and 3 will have a shadow price that is not equal to 0. All others will have shadow price of 0. Similarly, if you solve a DMU for, if you solve a DEA for DMU2, 1 and 5 will have a non-zero shadow price. We will see that problem now. We have a numerical, we will work it out now. It will give you more clarity. Is it fine?
Just a correction, sir.
Yeah.
DMU3 5 and 4 would be non-zero.
Yes, sir. You're correct, sir. Thank you. All right. So this is the theory behind DEA. Is the theory clear?
Yeah.
So
Yes,
what did we see? If you have to summarize DEA, we want to maximize the efficiency, and efficiency is a ratio of output by input. So first we are linearizing the problem by equating the denominator to 1, and that is called a type constraint. And then we give a explicit condition saying that the output should always be less than or equal to input. And then we have the constraints that, so these are the constraints. Okay, and then we saw something called hypothetical composite unit. So how do you make an inefficient DMU efficient, right? So now we will solve the problem theoretically. Okay. So if you go to non-graded assignment, right? So let's solve a particular problem. What is this? Graded assignment. Yeah, this one. So let me copy paste this question on chat so that you can try to solve this question. Try to solve this question. You can expect some kind of numericals in the exam also. I will also read the question. So there are 6 business units. So there are 2 outputs and one input under consideration. So you are solving an optimization for business unit 3. Your efficiency is 0.7. So what happens? We are solving for DMU 3 and apparently it is not efficient. So the efficiency is only 70%. So therefore, now you are trying to make it more efficient. You find the dual variables corresponding to constraints of business units 4 and 5 are non-zero. So for business unit 3, business unit 4 and 5 are reference units because they are non-zero. So the dual variables, right, the shadow price for business units 4 and 5 are non-zero. So therefore, this 4 and 5 are going to act as reference units for business unit 3, and the other dual variables corresponding to the constraints are 0. Only the 4 and 5 are non-zero. The all other dual variables are 0. The only reference points for business unit 3 are 4 and 5. The dual variables corresponding to the constraints of business unit 4 and 5 are 0.3 and 0.4 respectively. So now tell me, what is the sales in HCU3? So now you have 0.7 efficiency. From 0.7, you want to move towards 100% efficiency. So which means what they have to do? Do they have to sell more or less? Do they have to sell more or less? You want to improve more. Similarly, the number of leads should also be more. So how will you solve this? What is the sales in HCU3? How will you solve this? Let me open Excel and then show you. So we have 2 outputs, sales and leads, 10,000 and 8,000. Leads are 10 and 12. Okay, are you able to solve this? Or do you need help? What else do we have? What more information do we have? We know that the dual variables corresponding to business unit 4 and 5 are 0.3 and 0.4. So now I am asking you, what should be the sales in HCU3? HCU3 sales. How much should it be? How will you do it? Any idea? First try this. 0.3 into 10,000 plus 0.4 into 8,000. How much answer you're getting?
6,200.
So let's check the answer. It should be wrong. What is the answer we are getting? Is it matching?
No.
8856 to 8858. Okay. We are not getting the correct answers because if you add this shadow pricing, it should add up to 1. So are they adding up to 1?
No.
No.
So how do you make it to 1? This is called normalization. How will you normalize this? First compute the sum, then you divide this by total. Similarly, you divide this by total. So now if you add, what will happen? Now is it equal to 1?
Yeah.
But in your exams, be very careful, okay? Because we have to round off here, right? We have to round off here. If you don't round off, the answers will be very, very different. So let's say, let us round off to 3 decimal places. So if you round off this to 3 decimal places, how much it will be?
0.428.
Next one, 0.571.
Yeah.
And if you add it, it won't be 1, but it will be near to 1. That is fine. Now what I'm saying is, I want you to round this off. We will see the difference in the answer if you round off and if you don't round off. Okay. So let's say I'm rounding it off to 2 decimal places, because then only you will see massive difference. And this will be 0.57. Okay. This is 2 decimal round off. This is not rounding off. Okay. So now I will multiply this into this plus this into this. This is my answer. So now I am rounding it off to 2 decimal places plus this into this. See, do you see the difference in the answers? Unfortunately, we are in a setting where we won't be able to give you step marks, right? If I have given an instruction saying that round off to 2 decimal places in each and every step, you will have to do this. If I say you will have to round off for 4 decimal places, right? You will change it to how much it will be? 4285 or 4286. This will be 5714. The answer will be very different. If you round off, the answer will be very different. And don't tell me, sir, I followed all the steps, my answer is wrong, give me step mark. Because we don't have the degrees of freedom to give you step mark. This is an online setting where you will have to follow the instructions carefully. When if you miss one rounding off, the answer will be very, very different. So be very, very careful. First thing what you have to do is, when you get a problem like this, okay, I see a comment. I'm not able to see it because I'm sharing my screen. Let me finish this and then go back and check the chat. First thing, when you see this, check whether the efficiencies add up to 1. If they add up to 1, you can directly multiply this number with this one, the other number with the other one, and give the answer. If they don't add up to 1, you will have to normalize and make it to 1. When rounding it off, sometimes they may not be equal to 1. It will be 0.999 or 0.998. That is fine. Just follow the instruction, round it off, and compute the HCU in 3. HCU sales in DMU 3. Okay, I'll stop sharing and then we'll take up some questions and then continue. Yes, sir. What is your question?
Sir, I am telling that in that question, like you have done 3 by 7. So 3 by 7 into 1000. Okay, sir. So you have done already 3 by 7 and you have done round off. If we are not doing round off, we are doing like this: 3 by 7 into 1000 and 4 by 7 into 8000. Then what will happen? Because we are not going to do is round off, and it will take consume time, because here you have done 3 by 7 and we have find out one output. So if we are going to do 3 by 7 into 10,000 and 4 by 7 into 8,000, that will be and after that we are doing round off.
Okay, so you want to round off at that step. That is also possible. We can think about it. We'll decide now. Before today's class, we will see which is better. Because actually what you say is very, very correct. Maybe that is another interesting thing we can think about. Instead of finding, okay, that's a good idea. We can do that, right? Instead of rounding it off here, right? We will do 3 by 7 into 10,000 and 4 by 7 into 8,000, right? That should be the correct way of doing it. Correct, man. I agree with you. 3 by 7 into 10,000 and 4 by 7 into 8,000. And if you sum it up, 8857.14. Yep, we'll do this. Let's not waste time in rounding it off. Thanks for bringing this, man. So 3 by 7 into 10,000, 4 by 7 into 8,000, or 0.4 by 0.7 into 8,000. Okay, we'll fix this. Good. Any other question?
Sir, in the question, you have given dual variables corresponding to units 4 and 5 is non-zero.
Yes.
Okay. Is it for the binding condition? Binding not
No. Here, these are reference unit. So if you see here in this diagram, so assume that this is the DMU that for which we are solving the problem. When we solve for this particular DMU, let's say your efficiency is 0.7. Then when you look at the shadow price, the shadow price of units 1 and 5 are non-zero, which means this and this are the reference units. So you want to bring this 2 to this efficient frontier. Similarly, here, what is happening is this DMU3 is inefficient. And for this DMU3, DMU4 and 5 are reference units. Okay?
Okay.
And that's why the shadow prices or the dual variables of these two variables are non-zero. All other variables, there are 6 business units, right? For all others, the dual variables will be equal to 0. Only for these two, it is non-zero.
Okay, sir.
All right.
Okay, sir.
Okay.
And, just one more follow.
Yes.
For 4 and 5, it is non-zero, and then for others, 3 is inefficient, so we are solving it. For
3
others,
is
what will we do?
So here you have to solve the business DA problem for each and every DMU. Right now, I am giving you only one problem, which was solved for DMU 3, business unit 3. So you are solving only one problem here. Likewise, you have to solve it for DMU 1, 2, 3, 4, 5, and 6. There are 6 business units, which means you have to apparently solve 6 DA problems. Okay, but this is just a problem for your practice. I'm giving you only one problem. Okay, so today what we saw, we covered the theory behind DEA, what is the rationale behind DEA, how will you formulate a problem, and how will you make an inefficient business unit efficient, okay, through graphical method and through the shadow pricing method. Is it fine?
Yeah.
So,
Yes, sir.
similarly, in the next class, we will finish conjoint. My only request is watch the videos of conjoint analysis and then come. If you do that, you don't have to study conjoint analysis again for the final in-term exam. Okay, I will wait for 2 more minutes. I will stop the recording. I will stop the live streaming. Officially, the class is over. If you have doubts, you can stay and get your doubts clarified. So from my end, what are the things pending? I have to make sure that your practice problems for logistic regression